Hi everyone, and welcome to techniques and techniques and practices for testing Angular. I'm Adam Stephensen. I'm a solution architect at SSW. I specialise in building large enterprise web applications, and I'm lucky I've been building Angular and .NET Core applications since they were both in early beta.
My name's Duncan. I work with Adam up in Brisbane, and I've been really lucky over the last couple of years to just pretty much only do the new Angular stuff, and I spend about half my time writing code for clients and traveling, and the other half my time traveling around talking about it and teaching, which is really fun because that's where you really learn, because you get to see what everyone else is doing. So hopefully we can share some of that experience with you today around testing. So you're going to hear us say Angular 2, but what we really mean to say is just Angular, because the Angular team would like it if everyone stops using the version numbers in the naming, because it's been quite confusing, and we're currently at Angular 4, and soon we're going to be, probably next month, we might be at Angular 5. So the idea is that it's going to be evergreen, a bit kind of like Chrome. I think we're at 60, because I think I'm getting some touch bar features for my MacBook for Chrome in version 60, I'm not sure yet. But just like Chrome, you don't really know the number, Angular is going to be the same. So if you're talking about Angular, the first version, you should be saying Angular JS. And if you're talking about the second version or 4 or 5 or whatever comes after that, then it's just Angular. So you'll see us try our best just to say Angular. So who here in the room, hands nice and high, who's tested Angular JS? Okay, cool, probably close to half the room, that's good. And who here's done any testing with the new Angular? Okay, so I see a few half hands. So probably a third of the room. So you're all in the right place. We're going to be talking about all the new stuff that's in the new testing utilities for Angular.
So in 1979 was the first time that that testing was actually differentiated as a different practice to debugging. In 1996 we got XP, which had a real focus on testing. In 1998 we got SUnit by Kent Beck, which was the unit testing framework for Smalltalk, which is the first of the XUnit frameworks, which is really what a lot of our current testing is still based upon. In 2001, we got JSUnit from Pivotal Labs, and it's worth taking a note of them. They pop up a fair bit. And that was the JavaScript implementation of SUnit. In 2003, we got TDD, and in 2006, we got behavior-driven design by Day and North, which was like an extension of TDD with human-readable tests. And in 2006, we got Selenium for running our end-to-end tests. And in 2010, we got Jasmine from Pivotal Labs again, which was the updated version of JSUnit. In 2010, we got Angular 1, which is the first time I had a framework. Oh, you're in the. Yeah, which was the first time that we had a framework where the hello world was actually unit tested, which I was really excited about, because from the very first day, Angular 1 had a real focus on testing, which was excellent. In 2011, we got Karma from Google, whose original name was Testacular. And I really wish they'd have stuck with that, because I think that's pretty cool. In 2013, we got Protractor for running our Angular end-to-end tests, which uses Selenium under the covers. And in 2016, we got Angular 2. Now, I find the history of testing really interesting, because when you look back over it, we're using Protractor, which uses Selenium under the covers. We're still running our unit tests in Karma. We're still writing them in Jasmine. Jasmine uses BDD. We're still encouraging TDD. Like, the tools that we're using and the practices that we're using, they're not new. And this is by far the best coverage we've seen in any room of testing. We asked exactly the same question in January this year in London, and 2 people had done Angular 1 testing and no one had done any Angular 2 testing. And so it's always been a struggle to get people to do testing. And I think that's because it's traditionally been hard, and front-end testing has been harder than back-end testing. And that's what we're here to talk about today is, we think that Angular's made it a lot easier. The tools and the frameworks that Angular has given us have made front-end testing much more easy, and that's what we're going to cover today. So the agenda, we're going to talk about the tools that we've got for testing. We're going to have a look at Jasmine. We're going to talk about faking dependencies. We're going to look at the TestBed API. And we're going to talk around the challenges around testing asynchronous code with the async and fake async methods. And then we're going to look at end-to-end tests.
So let's jump in and talk about some of the common tools that people use for testing with Angular. But it's important to remember, like Adam said, that testing is not an afterthought for Angular. You know, it's been baked into the system from the ground up. And so much so, if you actually go to print out the documentation on angular.io, it's 99 pages long. So it's actually a fair bit, and that's just how to kind of use it, not sort of best practices as well. And I only know that because Adam actually likes to print out documentation and read it, which is kind of strange. But so there's a lot of information around. There's two main types of tests that people do with their Angular code. The first is unit tests, where you're just testing a small function or a small piece of section of your application. And then you've got end-to-end tests, which are completely different, where you actually run the entire application in the browser, and then you query the DOM in the browser and select elements and run tests against what they've got. The tools at the moment that are the most popular is Karma as a test runner, and then using Jasmine as the testing framework for the syntax and the assertions and all of the matches and all of the different spying and faking utilities that you get. But Angular is also a big part of those testing utilities, especially in the next version of it, the Angular 2 or 4 or 5. There's lots of different testing helpers we're going to go through. When you're doing end-to-end tests, then you've got Protractor is the main tool for running the end-to-end tests, but a lot of people are using Jasmine as their testing framework on top of that, so the syntax is very familiar across the two. There's other ones you can use. If you're used to using, say, Mocha and Sign-On, you could do that. And more frequently, I've seen people wanting to use Jest, and I've really enjoyed using Jest for running tests because they're much, much faster, and also running in Node, you don't have to worry in your CI process about having Chrome set up and other sorts of things, but you're still way out on the fringes if you're using Jest with your Angular. By far and away, it's almost like 99% of people are using Jasmine and Karma, and everyone's using the Angular utilities. So what does Jasmine look like? Well, if you look at an individual JavaScript test, they very often look like this, where you'd have an it or a single spec or a test, that's some of the words you'll hear. And they'll take two arguments in the function. The first is a string, which just describes the individual test. And then it takes a function as the second argument where you actually do your test. And you can see here we have a Jasmine matcher with the .toEqual, but there's a whole bunch of other kind of helping matches from the Jasmine library, library. And then you would normally wrap this test in a describe block, which is where you'd have a suite of tests. So inside this describe block, which also takes two arguments of a string describing the set of tests and the actual function that is where you put all your tests. So you might end up having a couple of tests inside these describe blocks, and you often end up nesting more describe blocks inside of this describe block. So if you were testing, say, a logout function, you might have another describe block just for that logout function because you'll have 4 tests around that one particular function. So it ends up being a nested structure, but that's the kind of the basics. So Karma is a test runner that runs in the terminal, and you can run it on your CI processes, and you'll get this output like this in the terminal. It will say it's executed, say, for example, 6 of 6 tests. And most people tend to run this on another screen just so they can have some room. And then you've got Protractor, and that's very similar, but the way that it actually runs your tests is fundamentally different, and we'll be running some of these tests today. So here you can see it's running in the terminal, and it's showing kind of that behavior-driven development kind of wording there. So the describe block is page, joke page, and then the next part of it down here is the individual tests running. So one of my other favorite testing tools is Wallaby.
He's such a fanboy. Duncan is such a fanboy of Wallaby that he actually got them to make stickers. So he got the first Wallaby stickers in the world.
I actually have a whole bunch of them here. If anybody wants a Wallaby sticker later, they can come get one. But who's used Wallaby? Who's heard of Wallaby? Oh yes, so it's getting more popular. So it's $100. I'll just get that out there every year. You've got to be into it, but it's great. If you're writing lots of tests or you really value testing, then it can be worth it. So this is what it gives you on the left-hand side of these tests here. You can see you've got a couple of green and red dots. So the red one's failing over here, and then on the other side you can see that it expected 2 to be 3. So what you'd get in the terminal you get right here. There's a bunch of other benefits. You get a lot of test coverage tools and other sorts of things, but that's kind of the real big bonus of using it. Angular CLI is also a really important testing tool because it comes with all of your testing harness set up. So rather than having to go set up all of these tools and get them to work together, you can just turn on the CLI and run. So it's a great way to learn to test, but it's also great for client projects and real projects. And we pretty much run the CLI on everything we do. So in summary for the tools, we think the CLI is awesome. and that you should be using it for most projects, and that Karma and Protractor and Jasmine really are the default for the community at the moment, and that you should check out Wallaby.js. It's pretty cool and can help out. And we'll be using it a bunch today, so you'll get to see it. So let's move on to talk about Jasmine for a second, and let's jump in and actually write some tests. So we've got this very simple application we're going to write some tests around today. It's a Chuck Norris jokes application, and you can click the button and it shows the next joke. And the reason I like this for showing testing is because it's insanely simple to understand what it's doing. It's just a component, and you've got some button clicks which talk to a component that talk to an Angular service that talk to a backend. And then you've got to think about how do you deal with all of those dependencies and fake out the things that you want to fake out. And we'll talk about your choices of how you do that. So it's very simple to understand, but we'll talk about the different practices you can use. Okay. So let's jump over into the IDE and let's actually run a couple of tests. If I come over into Visual Studio Code here, you can see that we have a very vanilla Angular CLI project that we've used to make it. And if we open up the source folder, we have this app folder, and inside of here we have a joke feature. And this joke feature just has a joke component.ts file, a joke service, and it has a spec file. And we'll show you more of the joke component, but I'm just going to write some of the simplest tests we can in Angular for now. So if we open up this .spec.ts file, and the build tool is looking for anything that ends in .spec.ts, so that's how it knows to run, Karma knows to run these files when you ask to run your unit tests. So if I give us a bit more room here, I'm going to come in and write a describe block, and I'm going to say that we're going to be testing a suite of tests here. So the name I'm going to give, we're going to be testing a component here, and we're going to be testing the joke component. And then down in here I can do an individual it block or just a test. And I'm going to start off with something very simple and say that it should add 1 + 1 here. And then down in here I can do a Jasmine expectation, and I can say that I expect 1 + 1 to equal 3. So of course this is going to fail, and I can open up the terminal at the bottom, and I can run ng to get a hold of the Angular CLI, and then just run test. And it's going to kick off Karma, and Karma's going to build our app and run our tests. So in this case, we expect it to fail. And sometimes I don't mind these sort of sanity tests in my application, because when you've got lots of dependencies to configure and lots of services to fake and other sorts of things, sometimes a simple test like this can be nice just to see that it's running and you've got all your dependencies lined up. So down here you can see that it executed 1 of 1 tests and it failed. This is your default experience with the CLI. And it expected 2 to equal 3. So I could come up here and fix this, and then it will just rerun, because Karma's watching by default. It'll watch the file save, because I'm automatically saving in Visual Studio Code, and then it's saying 1 of 1 successful. So I'm going to kill this now, kill the terminal, and I'm just going to push Command-Shift equals to open the Wallaby shortcuts, and then push start. So now we'll just run the rest of the demo with Wallaby, but pretty much it's doing the same thing. It's just running your tests, but it gives you a feedback right now in the IDE straight away. And you can get it for like Visual Studio and Webpack and a bunch of, not Webpack, crossing over here, WebStorm. There's a whole bunch of different IDEs it works for. So if I change this to be equal to 3, you'll see it will fail and show you the thing there. And then if I change it back, it'll rerun. And it's quite fast. It's usually faster than your experience with running Jasmine and Karma. But it feels a little bit as fast as Jess, which is super fast. So I'm going to come down and write the world's simplest Angular test now. So I'm going to do another it block here, and I'm going to say that it should have a title of, let's say, Chuck Norris jokes here. Chuck Norris jokes. And just going to copy this so we can test against it. So down in here, I'm going to have a constant here for our component. And this is going to be equal to a new joke component. And this joke component has a dependency on the joke service. So I'm going to get this red squiggly here because it's saying, oh, you got to pass in something for this dependency in the constructor of the joke service. And we're going to talk a whole bunch about this, but for now I'm just going to shortcut it and pass in null. Because we just want to write a really simple test. I'm just going to test the title on the page, or actually the title of the property in the class of the component, nothing to do with the HTML template yet. So in here then I can do another Jasmine expectation. I'm just going to say that I expect my component.title, and I really love this every day. I still get off on it because we've got TypeScript in our unit tests, which is great compared to what we used to be doing. So I get all this good IntelliSense. So I expect my component.title is going to be equal to the string of Chuck Norris jokes. And it looks like Wallaby's frozen up. I'm just going to restart that and rerun it. So then you can see down here it's passing, it's showing me it ran it in 2 milliseconds. But if I make this fail here, we can see that it's failing and showing us the message on the side here. So that's kind of the simplest way you can run an Angular test. And I still really like that if I don't have to deal with the HTML and I've just got a really simple service. But you'll see us get into more complicated tests now as we move forward. So we had a quick look at how we can just use the syntax here, and we had a look at how we can just new up a component or service. But we'll talk more about other ways to make your dependencies for your tests. So in summary, Jasmine really is the default still for the Angular community in terms of your testing framework. It's more than syntax. So, there's a lot of helping functions and fakes and spies and sorts of things like that, which we'll show you now.
Awesome. Can I just get, can I switch over from the handheld to this one? Because as I'm coding, this one's going to be much easier, if that's okay. Yep. Awesome. Excellent. Okay, so we're going to talk about faking dependencies. So the faking and setup of dependencies is still one of the hardest parts of testing. So it doesn't matter what testing you've been doing, whether it's back-end testing or front-end testing. If you're trying to test a unit of code and that code has a lot of dependencies, managing those dependencies and testing around those dependencies is one of the greatest challenges. And we have that a lot when we're testing our Angular applications. So we're always injecting services. So this is the code that Duncan had. We were instantiating a joke component, and he was just passing in null. But to be able to do any real kind of tests, we need to be able to work with that service. So what's a very common pattern is that we'd go and create a fake object. We'd create our own object, we'd put a function onto that object, and it would return something that we knew, so that then when we're asserting against our component and against its behavior, we can expect what that dependency's behavior is going to be. So we take that fake that we created and we pass it into our service and we can run our tests. An alternative method to creating our own fakes is to use Jasmine spies. So what we can do with the Jasmine spy is that we can take an object, pass it in, and then we can put behavior or override behavior on that object. So in this case, we're taking a joke service and we're saying, let's get the getJoke method and let's attribute this particular behavior. So it's going to return a value, and the value it's going to return is an observable of fake joke. Now, why spies are great is they let you intercept any function call. So you can use your real service and intercept the function calls, and you can override the behavior of that function. What's really great about spies is they also let you check the interaction between your class or your component and the dependencies. So we can check to see whether the joke service, whether that getJoke method was actually called. We can check how many times it was called, and we can even check what parameters were actually passed to that getJoke method. Let's go and have a look at what that might look like in code. So I'm going to create a new test, and the test that I'm going to create is it should set the joke property when initialized. So let's go and just jump in and have a bit of our look at our joke component. So when our joke component is initialized, ng on init executes, and we execute the getJoke method. The getJoke method calls our joke service, calls its getJoke method, and it takes the observable that it returns and then maps it into this joke property on our component. So what I want to do is I want to check when the component's initialized, this joke gets set, the joke property gets set. So I could come down here and I could come in, and like Duncan's done, I could just come and instantiate a new component. But what I'm going to do is I'm going to lean on Jasmine a little bit, and I'm going to use its before each functionality so that I don't have to, in every single test, actually have to instantiate a new component. So I'm going to come up here and declare my component at the component, and I'm going to say it's going to be a joke component. And then I'm going to use a before each to say, when I come in, say that my component is equal to a new joke component. And just like Duncan did for the moment, I'm going to pass in null. And now because I've done that, I can come and remove the instantiation of my component from out of the test. And Duncan's test will still pass. Okay, so I don't need to do that now down in my test. So our test, we're looking to set the joke property when it's initialized. So I want to come in here and on my component, I want to call the ngOnInit method, which is what happens when it's initialized. And then I want to do an assertion, and I'm going to expect that the component's joke property is equal to something that I know. Say fake something, okay? Now, how am I going to do that? I'm going to inject a dependency into my joke component for my service. So I'm going to come up and I'm going to create a fake joke service. Fake joke service. And I'm going to say just my fake joke service can be an any. So now in my before each, I'm going to say that my fake joke service is an object. And on my object, I'm going to come in here and I'm going to put a getJoke method on it. And what I'm going to do is I'm going to say it returns an observable of fake joke. Now I don't know, I need to come up here and import I'm just because it's a test, I'm going to import the RxJS kitchen sink. I obviously wouldn't do that in my actual application. So now I've got the of keyword. And now what I've done, now that I've got this service, I can inject it into my component and I know what that service is going to do when I call the getJoke method. So I can come down here and I can see that Wallaby's already telling me that it's going to work, because now I can check and I can say my joke, the joke on the component, I'm going to expect to be what I passed into it. So that's using a fake object. I could come in here and instead of doing that, what I'm going to do is use a Jasmine spy. So instead of creating my own object, I'm going to come in here and say that the fake joke service is equal to Jasmine.createSpyObject, and I'm going to pass in my fake joke service, and then I'm going to pass in an array, and that array is the methods that I want to specify on that fake joke service. So I'm going to pass in getJoke, and now I can attribute the behavior that I want onto that getJoke method. So I can come in and go fake joke service.getJoke and tell it what I want to do. I want to return a value, and the value that I want to return is an observable of fake joke. And if everything lines up, my test is passing again. So that's two ways of doing the same thing. I created an object and passed in a fake object, and then I created a Jasmine spy. Now what's nice about the Jasmine spy is I can come down here and remember I can check how my component is interacting with that service. So I can come down here and I can say expect that my fake joke service's getJoke method has been called. Okay, so I can now check that interaction of my component under test with its dependency. So if I don't call the method by not calling onInit, it's going to give me an error. I could even come down here and check how many times it's been called. Oops. So was it called 3 times? No. Was it only called 1 time? Oops. Yes. Pretty cool. So we're getting a lot of extra power out of using Jasmine spies. So we had a look at injecting a fake object, and then we had a look at the benefits of using Jasmine spies. So the nice thing about faking is they're isolated. I'm actually going and creating an object that just has the behavior that I need. There's a few downsides. You can end up with a lot of duplicated code, and you can end up in the situation where someone goes and updates the behavior of the service, and they don't update the tests around it. So you can end up shipping something into production where all of the testing is working, but it's actually not running in production because the tests haven't been updated. The benefits of spying is that you've got the spying functionality and assertions, and you end up with cleaner code. So it's important to know that I've given you 2 strategies and 2 different tools, and you need to have both of them on your tool belt. Both of them you'll need in different circumstances, and the faking and setting up of dependencies is still one of the hardest parts of unit testing. And the TestBed is going to help you out.
Which is convenient because that's where we're up to. So let's talk about the TestBed API because that's one of the newer parts in Angular at the moment. So we're going to talk about a few different types of tests now because the testbeds help us solve a different type of test. So we've been writing these isolated tests where we're just testing the properties and the methods on a class, or it could be a component or a service, and we have no HTML template involved. Whereas in the community, there's this concept now, people are talking about shallow tests, where you're testing not only the component's class, but you're also interacting with the HTML template that's involved and being able to select the HTML template, query, say, an element on there and check its value, then run detect changes and do some work with the test and then see if things have changed. There's also integrated tests where you're testing more of the app, more components at once, or the entire application, but we're just going to look at isolated and shallow tests today. So we're going to use this testbed, and the main thing you're going to use it for is configuring your tests. So you can come in and say testbed.configure testing module, and being a hint in the name there, it sets up a module for you. And if you've done any Angular, it's just like an Angular module, and you can pass in all the parts of what a normal Angular module would need. And being an Angular module, what it does is it says, for this section of my code, these are all the dependencies for it to be able to run. So for this set of tests, these are all the dependencies for this set of tests to run. And it's one of the pains in the butt of doing front-end testing is setting up all your dependencies. So this can really help. So the first thing we have here is imports, and that is all of the other modules you depend on. So we have a HTTP dependency in our joke service. So I'm just bringing in the HTTP module. I have declarations, and that just is another fancy word for components. So we have the joke component, which is what we're testing. And then we have providers, and that's where you register your services, your Angular services, so we're registering our joke service here. So once we have this testbed, it gives us a hold of this fixture, and that's kind of the second probably the main reason you want to use testbed is to be able to get a hold of HTML templates, not just because it's super easy to set up dependencies. So you can use the testbed to set up your dependencies for a service which has no template. But this testbed.create component and then passing in the joke component gives us this fixture. Once we have this fixture, we can get the component itself again, which means we've got the properties and methods accessible. But we can get this debug element, and it's this fixture.debug element we can use to query the HTML template associated with the tests. And we can do a bunch of other things like run fixture.detect changes so that after you do some things in your test, it will then go and update the change detection so the things are bound to the page again that you've done in your tests. So we can say fixture.debugelement.query, and we can query by CSS. So any CSS selectors you're used to using, you can use them here to be able to query the DOM to grab whatever you want. So in this example, I'm grabbing the paragraph element. And I can call .native element if I'm running in a browser environment to be able to interact with that p tag as if I am in the browser. So this is going to give me all of the browser-specific API surface area for this p tag. So the testbed's really great because it can really help make a testing module and give you this kind of system for building up all your dependencies for your tests, because it gets much more complicated than this when you have 6 dependencies or 6 services and 2 or 3 components and the router and HTTP and all sorts of things. You can query the HTML templates with it, you can run detect changes, and you can do a whole bunch more. So it tends to be the go-to for most of your tests. But if I can, I still like to just new up a class if it's something simple. So let's jump over and actually configure our current tests to use the testbed and run a test against the HTML template and do a couple of different tests in that way. So I'm going to jump back over, and I'm going to take a little bit of pleasure in getting rid of Adam's tests.
I'm standing right here.
Maybe I'm enhancing them. Okay, so we're going to say that we want to have this fixture property, but we're going to initialize it down below. So I'm going to say let fixture of type component fixture, and the type of component fixture is going to be the joke component. And then underneath here, we're going to need to get a handle on the component as well. And this is going to be of type joke component. And then we're also going to get a handle on the almost did company there, and joke service here. So we want a property for the joke service, and that's going to be of type joke service. So if you've done much testing, you're probably going, whoa, wait a second, you're passing in the real service here. This is a decision point for all of your teams. What value do you want to get out of your front-end testing? So I'm going to pass in the real service here, but make sure that I'm going to intercept it, and I never actually call the real backend that the service can. And if I had more time today, I would also fake out the HTTP section, so I really can't stuff up and call the backend. But for now, we're just going to intercept all requests out to this service with the SPI. But I like this because, one, it's easier to configure, but two, it's giving me a little bit of more, and this is my personal opinion, it's not black and white and it's not right and wrong. Because then if someone changes this joke services methods and properties, now my tests will break as well because I'm actually interacting against the real joke service. So this is definitely something your team is going to need to decide on. What flavor do you like to do? Do you want to test more of it and get a bit more kind of integration sort of testing in a unit test? But for now, that's what we're going to do. So I'm going to come down here and I'm going to get the test bed, and I can call configure testing module on it, and that takes in an object. And the first thing we're going to do is imports, which is an array, and we're going to pass in the HTTP module, and then we will get declarations, and that is also an array, and we only have joke component in this example. And then we have our providers, so you saw this before, and this is going to be the joke service that we want to register with Angular inside of these providers. So once I have this, I can use this test bed to initialize all those properties above. So I want to get this fixture because I want to interact with the HTML template. So I'm going to say fixture is going to be equal to the testbed.create a component for me, and the component I want you to make, please testbed, is this joke component. And with that, I can start using this fixture for lots of things. So next up, I want to get the component, and I'm going to initialize that with this fixture. And I'm going to say, hey, fixture, can you please give me a handle on the component instance? And then also I'm going to use this testbed to get a hold of some dependency injection. So this is a different way to doing dependency injection in Angular, the newer Angular than before. So I can say that I have this joke service, and it's going to be equal to the testbed.get. And there's a whole bunch of different helpers on this testbed. This is just one of them, and I want to get an instance of the joke service. So I'm going to ask it to inject that joke service so it's available in my test. But now I've actually got the real service, so I've got to be careful with what I do here, and I've deleted Adam's service. I'm also going to delete his test here just for fun. And I'm going to come in here and make another test. So I'm going to say in this one, now I'm not saying we should initialize the property, we should have the HTML template with the text actually on that template. So in here I'm going to say should have a joke bound to the template. So inside of here, I'm going to need to show you another way that you can use a SPI. Exact same thing, just a different syntax. So I'm going to spy on here the company service. Joke service. I can hear some people helping me out here. We just ran a 2-day workshop where everything was about companies, so I apologize. So just switching entities in my brain. So joke service here, and I want to spy on the get joke method. And then I can go down here and say and we'll see all the different things that are available on a SPI. So I could call a fake or call through, but in this case I want to return a single value. So what I want to return here is going to be an observable.of the string of the joke. So for now, let's just say something that's not looking like a joke, like fake joke. And then underneath here, what's happened is we've just instantiated this joke component, and we've gone and make this request, and the SPI's intercepted and given back this fake joke, but that's changes, so we have to actually run fixture.detect changes here so the HTML template will update. So I'm going to come in here and use this fixture again and say here that I want to say fixture.detect changes and execute that. So now the HTML template will be updated with that fake joke string. And then down in here I can set up a constant of joke paragraph element. And it's this joke paragraph element I'm going to use from the actual HTML. So here I can say fixture.debugelement.query, and I can query by .css, and the CSS I'm going to query by is this p tag, and then I want to get a hold of the native element of that. So I'm going to need to import by from platform-browser, so this is the browser-based thing. And then down underneath here, I'm going to do a Jasmine expectation. I'm going to expect that my joke paragraph.text content is going to be equal to the string of fake jokes. So let's just see if this will fail first. I've done a whole bunch here, so I'm actually just going to restart Wallaby for a second. And that should kick back in and say, you're expecting fake to equal fake joke, so let's just finish that off. And now our test's passing. So that's pretty cool. We're actually grabbing the HTML template and checking the P tag. So of course this is going to be more brittle, and now you're more invested in keeping up to date something that's married to the template as well, but that's quite powerful. So we had a look at how we can set up the test bed in the before each, and how it can be much easier to actually set up all your dependencies, because when you do a lot of Angular, you're making modules all the time, so it's the way you're used to doing it. And then we were able to use the debug element to query by that P tag. So it's a pretty big API. There's lots of things you can do with it, this test bed. So it takes a bit of time to learn and get comfortable with, but it's well worth it. You use it in all your tests. And it helps you make basically an ng module to set up your dependencies, and then it runs everything in a zone. And if you're a little bit like me, the very first time I heard the word zone, I'm like, what? A zone? So I'm going to pass you over to Adam, and he's going to talk about zones.
Awesome. So I'm going to talk about the challenges around testing asynchronous code, because asynchronous code adds complexity to writing your JavaScript unit tests. If you've got, it's quite simple to have a form with a button on it. The button calls a service. The service makes a HTTP request, which returns something. And then when you're doing your test, you want to assert that is all of that working together. But the challenge is around that asynchrony. So how we've been doing that in the past is with Jasmine done callbacks. And they work by using a promise and then calling done. The downside of Jasmine done callbacks is they require chaining promises, handling errors, and then calling done explicitly. And while we don't actually really recommend them or like using them that much, we still need to use them sometimes around some edge cases. What we've got now, which makes life a lot more fun, is the async method and the fake async method. And really the key to them is zones. Does anyone want to try describing zones? No? I'll do it. Okay. So zones aren't difficult. I just think they're a little misunderstood. Okay, so here's the textbook definition, is that zones define an execution context for asynchronous operations. So what happens when you're executing your asynchronous code in Angular is that it executes within a zone. So whenever you kick off an asynchronous operation like a button click, what happens is a micro task is put on a queue. When that task completes, the micro task is taken off the queue. And why that's really powerful is Angular's aware of when there's outstanding asynchronous operations. Now, when we come to testing, it gets even better. So we've got the async and the fake async keywords, and what happens is when you wrap your tests in the async keyword, they're now going to execute inside a testing zone. So what happens now is when I do something like do a button click, in the testing zone, I'm putting a micro task on the queue, and I can now use fixture.whenStable to know when all of the micro tasks have taken off the queue and all of the asynchronous operations have completed. So it's going to make our testing much easier. So when we're writing, so fixture.whenStable, it resolves when all pending asynchronous activities within the test completes. So it makes it much easier for testing async in our Angular apps. Now there's fake async, and fake async is similar to async, but instead of using when stable, we actually use the tick method, and tick simulates the passage of time until all of the pending asynchronous requests complete. Alternatively, you can specify a number of milliseconds to simulate waiting. Okay, so what's really nice about fake async is instead of waiting for when stable, it's actually a much more linear progression through your test. Let's go and have a look at what that might look like. Now, I'm going to do a test, and the test I'm going to do is I'm going to say it should get the next quote on button click. So Duncan's previous test should have a joke bound to the page, said when the page is initialized, we should go out and get a joke from the service and bind it to the page and check that. And that was nice, but I'm going to take it the next step, and I'm going to say, let's do that. But when the button's clicked, it should go and get another joke, and it should bind that to the page, and I want to test that as well. Now, Duncan keeps deleting all my code, but I'm more of a copy his code and steal it kind of a guy. So I'm going to take the code off his previous test, and then I'm going to go and make it better. So what he was doing was he was creating the spy, then he was doing a round of change detection. He was getting a handle on the joke paragraph and checking the text. I'm now going to go and get a handle on the button. So I'm going to create the button. I'm going to say fixture.debug element, and I'm going to do a query by CSS for a button, and then I'm going to get the native element. And what's really cool is I can just go button.click. So I've now I've now actually clicked the button. So what I'm going to do now is I'm going to come in, I'm going to need to do another round of change detection. So I'm going to do a detect changes. And now I'm going to do my assertion, and I'm going to say that I want my joke paragraph's text content to be equal to something else. Okay? But at the moment, my return value is only returning a single value. And I'm going to go and query the service twice, once when the page loads and once when I hit the button. So I'm going to change that to return values. And then I'm going to come in here and put another value in. What I'd really like to be able to do is come in here and go observable of fake joke 2 and put a delay on it of, say, 2 milliseconds, because that would be a cool test to simulate waiting longer on the second one. I'm not going to call it a bug, but let's say that there's still some work going on to make that happen for me. So what I'm going to do instead is I'm going to come in and I'm going to do an observable timer, and I'm going to say wait 2000 milliseconds and then do a map. And what I'm going to do after my map is then I'm going to return fake joke 2. Okay, and that'll do the same. That'll do the same thing. So now the first time I request something from the service, it'll return fake joke. The second time it's going to wait 2 seconds and then return fake joke 2. Now, you can see here I'm having some issues, obviously. So the button's getting clicked, I'm doing detect changes, and I'm still getting the initial fake joke because it's waiting 2 seconds to send me the second message. Does that make sense? So what I want to do is I want to take control. So I'm going to wrap the whole test in fake async. Okay, and that's going to give me the ability to actually take a... Oh, what did I do wrong there? I missed it.
Well, I think you put it on the very bottom, closing of the whole class.
Yeah.
Or the whole func. There you go.
Do it again.
There we go. It looks like the compiler was just slow to catch up.
No, I've taken it out.
Oh, okay.
Oh, you think it's waiting for me? Let me try again.
Suspense.
Suspense. There we go. That's better. I actually was putting it in the wrong spot. Okay, awesome. So now what I've done is I've wrapped the whole method in fake async. And what wrapping the whole method in fake async gives me the ability to do is to come in here and go, after I click the button, what I want to do is I want to come and wait. Let's wait 2 seconds and see, and I'll need to import tick. See, I'm getting back. Now it's simulating waiting the 2 seconds, and now I'm getting back what I would expect, which is fake joke 2, and my test is passing. So the fake async method lets me control simulated time. What's really cool is that even though I'm just going to call out, even though I've got a 2 second wait, it only took 30 seconds to 36 milliseconds to execute the test, because fake async is working with simulated time. Now I'm going to show you a very similar test. I'm going to do exactly the same thing, but I'm going to do it with async instead of fake async. I'm just going to import async. And remember I said instead of using tick, the async uses fixture dot when stable. And then I'm going to say then, and what I'm going to do is I'm going to move my detect changes and my assertion up into when stable. Oh. Extra bracket. There we
Thanks
go.
for that.
Oh, I'm not having luck with brackets now, am I? There we go. Okay. So I'm going to use when stable now because I'm using an async method instead of tick. And you'll see in a second when it reloads that my test is passing. Okay, so it's doing the same thing, but now I don't have that linear progression. The other interesting thing is you can see my async test is actually using real time, so it's actually taking the full 2 seconds to execute. So we had a look at using the async wrapper, calling the button click, and then using fixture.whenStable to resolve our async tests, as well as using fake async and using the tick method. The benefit of async is it really does simplify coding our asynchronous tests. I prefer fake async a lot of the time because the tests appear to be asynchronous. The challenge with fake async though is that there's some situations where it doesn't work. For example, you can't make XHR requests. So in summary, testing is still, writing testing codes can still be a little edgy. But the new helpers that we've got around with async and fake async make life a lot easier.
Cool. So these bits are cool, and we're looking at writing unit tests, but let's actually shift gear a little bit now, and let's actually write a couple of end-to-end tests to finish up. So the end-to-end tests ensure that integrated components function as expected. So you got to take that mind shift of going, what I'm really doing here is running the entire app in the browser. I could not actually know that it's Angular in a way, and then I'm selecting things off the page and checking that they're actually what they're meant to be. So usually they're very different. They run a lot slower. You usually tend to run them when you're checking in your code or when you're actually writing them. You don't let them sit there spinning away like when you're writing or if you're going to be doing test-driven development sort of thing. And usually you're testing more of a user's story where they log in, navigate to a page, click a button. So it's a very different motivation for these tests. So let's go write some very simple tests around end-to-end tests around the joke, testing the joke title and also around the joke button. So it's kind of similar to what we did with our unit tests in a way. So if we jump back over to Visual Studio Code here, I'm going to close this down and just open back up Explorer here. And you can see at the very top we have this E to E folder, and that was put there by the Angular CLI. And you get a default test out of the box. I renamed it to be joke.e-spec.ts. But if we open this up, we can see here that it's empty. And the very first thing I'm going to need to do is import a couple of helpers here. And I'm going to get these from Protractor, because that's what we use for writing these tests. So I want to get element, so I can select some elements. I want to get by, so I can actually do that CSS selecting. And I also want to get a browser helper so I can navigate around. So then I need to make another describe block. So you can see we're using Jasmine again, so it feels very familiar. So here, my motivation is really different. Now what I'm actually testing is a page or a set of pages in a lot of cases. But in this case, we're testing the joke page. And I like to think about it like a page versus a component because I'll have lots of components on a page normally. So in this case down here, I can come down and make another individual spec here. And I'm going to say that it should have a title of the similar sort of thing here of Chuck Norris jokes. And I'm going to grab that like we did before, just so we've got the same thing again. So down in here, what I'll kick off by saying, hey browser, can you go get to a URL for me? And I just want to go to the base URL for application. We actually have no routing because it's a really simple app, but just go load the page and navigate to here. And then what I want to do next is I want to get a hold of our title. So I'm going to set a constant of title, and this is going to be equal to element by.css. And I want to grab the h1 element because that's what we've got our title of our application in. And then once I've got a handle on that, I'm going to use the get text function to be able to actually get the text. So you can see the syntax is slightly different here from protractor for the helpers, but it feels very, very similar. Then once I have this, then I can do a Jasmine expectation again and say that I expect my title to equal the Chuck Norris jokes here. And missing the quote on the end there. Now I don't have any whiz-bang wallaby here to spin this up and run really fast because that's not what end-to-end tests do or how they work. I have to actually run this and it fires up the browser. So I'm going to give us a bit of room and move this over to, come out of full screen and move this over to the side here. Just get rid of these. And if you're very fast like Superman, you'll see when I run ng e to e down here in the terminal, you'll see it'll spin up the browser on the side. The default's going to be Chrome. And it's going to navigate to the root of the application, and then it's going to query by CSS for the H1 tag, and then see if it equals Chuck Norris jokes. So it spins up, runs, checks it. Doesn't seem to be able to find it.
Slow Superman.
Slow Superman. And we have an error. So error is timeout failure. Interesting. Let's kill that down and let's actually run that one more time. So ng e to e, and let me just glance over this. No, you can do by CSS, .get text and element title. Let's have one more run at it. Whoops. Down into the terminal here I want to go. Time for a cup of coffee. Runs. No, it looks like it's stalling to query for it and find it, which is kind of interesting. By browser protractor spelt right. Failed timeout waiting to find it. So unfortunately, my demo here for the last demo of the day is failing on us. But we've been pretty lucky so far. I don't think we're going to want to watch me debug a test live. But some people might go, yeah, this is where the action happens. Because the current page is not an Angular application.
Locator by CSS selector H1.
By.css.
H1, that's right. Yeah. We're going to take questions straight after the talk outside, and if anyone wants to come and watch us work out what the issue is, you can come and join in.
But you can basically see the gist of how these tests work here. So you'll navigate to the page you want to get, and you'll use these helpers to select queries off the page, and you'll run these tests. So I think most likely my problem here with my test is probably something to do with my dependencies or something else here versus the actual code in the screen, because I've run this a bunch of times. But if we move back here over to our slides, we did have a quick look at how we can run a test, and we use the similar syntax here to actually and you can see the exact code here. So by.css here for the H1, and then we're expecting the title to equal. And you can also run other tests. So in this case here, what I'm doing is I'm navigating to the root of the application, and then I'm selecting the first joke, and then I'm doing a button click, and then selecting the second joke and expecting that the second joke will have been set onto the page. So you kind of end up doing a few different things here in these end-to-end tests that you do. So in summary, they're not a unit test. They run in the browser, and they usually test a much more broader user story. Your motives for writing for an end-to-end test are going to be very different than testing a function. And they help save a lot of manual testing. You imagine you can automate a lot of this across multiple browsers, and for regression testing and large code bases, they can be super invaluable. And that kind of leaves us with like our summary of testing in our teams, I guess, is testing something that the whole team needs to practice. And it's something they need to practice regularly. It's not super difficult to do, but if you're not doing it regularly enough, you tend to be under pressure at work and you don't want to jump in and write the tests because you're running out of time. But if you do practice regularly, they're not actually so difficult to get in the habit of doing a lot of. So we also run a lot of courses, a lot of 2-day and 3-day courses. So we have a whole much more than we cover now in our coursework. So if you want to get that for free, you can use this coupon. So you can see we have a whole bunch of coursework that goes through using all the things that we've demonstrated and more. So if you go to courses.firebootcamp.com, you can go to NDC-Sydney-2017 is the coupon it'll ask for when you try and actually click on the lesson. and then you can put that in, that coupon, and then you've got access. So we'll leave that open for a day.
So all the demos we did today are in that course.
Yeah, so everything you want to get. Don't forget, Adam's favourite colour is green, and we love green.
And we'll be just outside the door afterwards if anyone wants to ask questions or get that coupon because you didn't quite get it down.
Yep. So we had a look at the tools that everybody's using today. We had a look at Jasmine and being the testing framework. We looked at how we can fake dependencies with Jasmine spies. We looked at the TestBed API for helping set up our tests. We had a look at async and fake async to help with asynchrony in our tests. And we had a look at a couple of end-to-end tests. Thank you very much, guys.
Guys, this is our Twitter handles. Make sure if you say hi, if you see us around the conference. And thank you very much.